What's up, guys? It's Mr. Brengle, and today we're going to be talking about the parallel circuits, V equals I times R calculations concept builder from physicsclassroom.com. In previous videos, I've covered the series circuit calculations, so make sure to check that out if you're trying to complete that one. As with the series circuit calculations, the apprentice level is just a one resistor circuit. So in this case, it's not even a parallel circuit. We're not going to cover that one, even though you may need to still complete it. Instead, I'm going to focus on the master and wizard level. And in this video, I'll do master level. And then in another video, I'll do the wizard level. So let's jump right into the master level here. And let's just go ahead and get our equations written out at the bottom here that we might need to use, which is all the same equation, just rearranged for different values here. And whoops, that's not what I want. We'll do current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. Okay, so if you kind of follow my mouse here, what's going on here is you've got the battery. The current is going to go out through point A. At point A, you're going to have your total amount of current. It has not branched off yet. So if you think about this like a highway, at the moment, it's a single lane highway. All the electrons are moving at the same speed. But then at this point, it branches off into a two-lane highway. You now have lane B and lane C. And part of the current will be in lane B and part of the current will be in lane C. But if you add those two lanes together, it should still equal A, right? So on a highway, if this was an actual highway, and let's say you have 10 cars in a single file line at this point, and then they split up into two lanes and 6 of them go into lane B and 4 of them go into lane C, well, there's still 10 cars on the highway. They're just in two different lanes, right? So the cars from lane C come back around and actually meet back up with the cars from lane B right here, and then it turns back into a single lane highway. So again, you should have the total amount of current at point D here. So A and D are going to be the total amount of current. You can actually see in this first example that they have the same numerical value there, and that is the way that it should be. So the point is that if you add up the current in branch B and C, it should be equal to 5 amps in this very first one here. So hopefully we understand that. Now, just to go through what they've given us, each horizontal row is a problem. So we're going to be going through problem number 1 first, then we'll move on to number 2. So they're giving us the battery voltage. There are 2 resistors here, resistor 1 and resistor 2. And then it wants to know the current at all of the different points. Again, A and D should match. B and C should add up to that number. Okay. All right, let's go ahead and do some calculations here. So first thing is that we need to solve for the current in branch B. And in order to do that, we're going to need the battery voltage and the resistance of that resistor, which are here and here. Now, in a parallel circuit, the battery voltage is applied across every branch of the circuit. So that means if you only have one resistor in that branch, like we do in this case, then you're going to drop the entire battery voltage across that resistor. So 6 volts will be dropped across R1, and 6 volts is going to be dropped across R2. Since it's given us the individual resistors of 2 ohms and 3 ohms, we can go ahead and calculate the current going through each of those using this equation down here. Current is equal to voltage divided by resistance. So we're going to divide 6 volts that's dropped across that resistor by 2 ohms, and we're going to get 3 amps of current going through branch B. And then we'll do the same calculation here just for the purposes of doing it, even though we know that this is going to be 2. 6 volts is dropped across R2, divided by 3 ohms of resistance at R2. That is going to give us 2 amps of current. And these two numbers here, 3 plus 2, does equal 5, which should be correct. Okay. So we'll move on to the next one now. Notice that it has given us the current at point A, which is 2 amps. And it has not given us the current at point D, but we know that it's 2 amps because the current is going to be the same whether you're looking at point A or point D. They're equivalent parts of the circuit. So we'll go through that same calculation again. We're going to take battery voltage, which is still 6 here, divided by resistor 1. So 6 divided by 4 is 1.5. for the current going through the first resistor, or the branch B, and then 6 volts dropped at R2 divided by the resistance at R2. 6 divided by 12 is going to give us the remaining 0.5 amps that are going through branch C. When you add the branch B and C together, it does equal 2. Okay. All right, so we'll keep moving here. Now, in this next one, let's go ahead and calculate the current in B and C, and then we'll add them together to get A and D. So we're doing that same process here. Battery voltage 12 volts divided by resistor 1, that is 3 ohms. That's going to give us a current of 4 amps through branch B. And then the battery voltage 12 volts divided by resistor 2, 6 ohms, is going to give us 2 amps at branch C, and then those add up to 6, and that's what we'll put in for A and D. Now, at any point, you can check your answers to see if what you're doing is correct. So if you filled out a row and you're like, man, I'm not sure if I did that correctly, I just want to check real quick, you can do that. If you get an incorrect answer, it's going to highlight it in red, and it will subtract from an overall health bar that you have. So you have 100% health to start with. It'll subtract a certain percentage of health. So you don't want to be just putting in random numbers and checking it, but it's a good tool to see if you're on the right path. So moving on here, next one is exact same situation. We're going to calculate B and C first, then we'll calculate A and D. So the current at going through branch B would be the battery voltage 24 divided by the resistance at resistor 1. So 24 divided by 2 is going to give us 12 amps of current in branch B. And then 24 volts divided by 8 ohms of resistance in branch C will give us 3 amps of current in branch C. And then we know that there's a total of 15 amps of current because we add these two together. Okay? And we can always go and check our answer. All right, now our last one here. It has not given us the resistance of resistor 2, but it has given us the current that's going through resistor 2. So we can use that to solve for this value. We can go ahead and solve for the current at B, add up B and C to get A and D, and then we'll solve for this resistor last. So doing the process that we've been doing this whole time, we're going to take the battery voltage that's dropped across R1 in branch B, 36 volts, divided by the resistance in branch B, which is 4. That's going to give us a total current of 9 amps through branch B. When you add branch B and C current together, you get 15, which should be the current at A and D. Now the final step is to solve for the resistor right here. So when we're solving for resistance, we want to take of an individual resistor, we want to take the voltage that's dropped at that resistor, in this case 36 volts, divided by the current that goes through that resistor, in this case 6 amps. So 36 volts divided by 6 amps is going to give us a resistance of 6 ohms at R2. Go ahead and check our answers. All right, so we've completed the master level here of the parallel circuit calculations. And make sure to let me know if you have any questions. There will be a follow-up video that goes through the wizard level of this concept build.